Okay, in this video we're going to take a look at some of the features, the sheet metal features of Solidworks. So we're going to model up this sheet metal box shown on the screen, and if you want to get the steps of the tutorial you can click, the steps can be found within Solidworks by clicking on Solidworks Resources, clicking on Welcome to Solidworks, clicking on Learn, clicking on Tutorials, and then click on Basic Techniques, and then pick up the design or sheet metal here. And as you can see, this lesson shows you how to create a sheet metal part using the base flange option, the miter flange option, and various mirroring techniques. And finally, we'll flatten the part to create a 2D flattened drawing of the part. Okay, so let's create a new part in SolidWorks by clicking on File, New Part, and making sure that we activate the Sheet Metal menu. So here we select the Base Flange tab option, and this allows us to generate a base or a flange on a specific plane. So here we picked the front plane, and we're going to draw a U-shaped profile and dimension it. So we're going to give the side dimensions 80 millimeters, or make the side dimensions 80 millimeters, and make the base 180 millimeters. So we can now add a few constraints. So first of all, let's make the left side equal to the right hand side. So we click the left hand side and the right hand side, and we add a relationship. We add the equal relationship, and next we would pick the midpoint of the base and align it to the origin and make sure the base and the origin are coincident. Okay, so once we do this and we exit the sketch, or when we click on exit sketch, this generates the base flange for us. And now we can specify specific lengths. So we want to make the length of this flange 75 millimeters. We can change the thickness of the metal. We can make it 1 millimeter, 2 millimeters, 3 millimeters. Here we make it 3 millimeters, and if we want, we can change the bend radii and specify some of these K factors. So here, once we do this, you can see in the feature tree, we have this sheet metal option, which holds the parameters for the sheet metal. So we can change the bend radius or the thickness if we wish. And if we go into the base flange and use edit feature, or use the edit feature command, we can change things like the width and the height of the flange. And finally, if we click on the flat pattern option, and if we unsuppress or suppress this option, we can basically flatten or unflatten the part. Okay, so next we're going to take a look at adding a miter flange to one of the edges of our sheet metal profile. So let's just collapse the items in the feature tree. And before we create the miter flange, let's create a cutout on the base of the sheet metal part. So we're going to draw a circle or sketch a circle. I'm going to make sure that the center of this circle is at the midpoint of the edge of the base of the sheet metal component. So we pick the midpoint and center point of the circle, and let's add a dimension, and we're going to make the dimension of this notch or cutout 40 millimeters. So once we create the sketch, just we can click on go to features, and we'll create a cutout through the base here. Just select the through all option and accept, and this will give us the cutout or notch that we want. Okay, so now we're ready to set up the miter flange. So click on miter flange. The first thing we want to do is we want to pick a specific edge. So we zoom in and we pick this edge. And now just let's have a look at the bottom profile or the bottom orientation of the part. And what we want to do now is draw a line. So zoom in there, make sure you get the end of the red baseline there. Just move it along a specific distance. Now I'm going to add a tangent arc. And this will give us, what we're really doing is generating the profile for this miter flange. And after creating the flange, let's draw a line and make sure that this line is tangential to the arc as shown. So we can now put some smart dimensions on these profiles. So let's make the length of the base here 20 millimeters, the radius of the arc 10 millimeters, and the length of this line. Let's make it 6 millimeters. Okay, so if you want, we can go into isometric view just so we can see what's going on. Well, first of all, just finish the dimensions, which I think we have enough there. So if we click on isometric, we should be able to see what's going on here. Right, so there's the profile. And if we now click exit the sketch, you can see that the miter flange begins to propagate along that edge. So we can specify the position of the flange, if it's inside or outside, the material is inside or outside. So this time, say I'm going to pick outside, material outside, and I'm going to click on the propagate option here. So this just brings the profile or the flange all the way around the two edges as shown. Okay, so you can see we've generated the miter flange, and now we want to get this on the other side. So we'll use the mirror feature option, but before we do that, let's just look at the back orientation view of the part first of all. And now what we can do is we can pick the face that we want to mirror about. So if we highlight that and pick the face shown, which is the mid plane of the part, and now if we pick the bodies to mirror, which is the entire sheet metal part, we can very quickly mirror that to the other side as shown. So next we're going to create an edge flange using the sketch profile and using some offset options. So click on the edit flange icon, pick the edge shown, and just bring it to an arbitrary position as shown on the screen and accept this initially. Okay. So once we have that done or created the flange, we can now go in and edit its feature. And in here we want to specify the length of the flange and also the side of the metal material around the bend. So what I'm going to do here is I'm going to change the flange length. So first of all, we need to set the blind option, change the length, the flange length to 30 millimeters, and we're going to specify the offset here. Well, first of all, let's change the flange position and make sure that the material outside option is selected, and the flange length, we need to specify that to be 30. Sorry, I put in 20 there. Make that 30 millimeters. So specify the length. That's the length that the flange protrudes out as shown is 30 millimeters. And then let's make the offset 15 millimeters. So once we have that done, we can accept. And now what we want to do is we want to drag the edges of the flange in if we can. So once again, go back into the flange, click on the edit feature, the edit sketch option, and drag the outer edge of the flange on both sides across as shown. So we now use Smart Dimension and give this profile some dimensions. So let's make the width of this flange initially 36 millimeters, and the distance from the corner edge to the edge of the profile, let's make that 36 also. And if we accept that, you can see what happens, that we have a flange which has a width of 36 millimeters and it's indented, if you like, 36 millimeters from the corner. Okay, so we'll accept this. So next we want to mirror this edge flange about the reference plane at the center of the part. So we'll click on the mirror feature option, pick the right plane, which is centered at the middle of the part, and then pick the features that we want to mirror, which in this case is the edge flange that we just created previously. So if we click on edge flange, accept, we get the edge flange on the other side of the part as shown. Now if we want, if we go back and edit the original edge flange, and let's change some of the dimensions here. First of all, let's get rid of this 36 mil dimension, and instead I'm going to add a dimension on the right hand side of the tab, as you'll see. So click on Smart Dimension, pick the corner of the profile, and then the corner of the flange, And let's specify a value for 36 millimeters. And you can see this is going to update the edge bend and the reflected option. Okay, so next let's add a tab by once again going to the sheet metal menu, clicking on the base flange tab option, and if we pick the top plane as shown, create a sketch, a rectangular sketch, pick one of the points along the edge and somewhere else arbitrarily as shown, and let's give this tab a dimension. So make the width 40 millimeters and let's make its depth 20 millimeters. So next we want to just constrain this rectangle. So if we go to add a relationship and pick the midpoint of the rectangle and align it with the midpoint of this edge here and make the 2 points horizontal. And that'll center the flange for us nicely. Okay, so next we're going to bend this tab, and we'll do this by using the sketch bend option. Again, we pick the top face as shown, and what we do is we create a line, and this line can be any length really, but we position it. Well, first of all, let's create it along parallel to the face of the main flange, and give it a dimension. The dimension from the bottom edge here, which let's make it 10 millimeters. So once we specify that, we need to click on the face that we want to bend from, which is below the bend here, and again set the options for bending inside or outside the material. So in this case we'll go material outside, and this will create the bend for us. So next we're going to take a look at adding a cut across a bend. Now we do this by unfolding the bend first and then generating the sketch and cutout and then refolding it. So click on unfold, pick a face and then pick the bend that you want to unfold, which is this bend here at the bottom. And once we have it unfolded, let's take a look. Let's do a normal view of the part first of all. So go and generate a rectangle. So go to sketch, rectangle, draw a rough rectangle first of all, give it some dimensions. So in this case, we can specify a length, the width of the rectangle is 14 millimeters, and let's place it 14 millimeters from the edge. Click on exit sketch, and then we can use our cutout option. So go features, extruded cut, pick the sketch that we want to use, and then let's go through all. And that should generate a cut through the bend for us, as shown. And once we have this done, we can now go and unbend it again. So if we go back to our sheet metal option, go to unfold, or fold this time, fold, pick the face, the reference face, and then pick the bend, which is this bend again, accept, and we can fold it back into position, and you can see that the cutout has been generated. So the last thing we want to do is create a closed corner on one side of the box. And we do this by clicking on the edge flange option, picking the edge that we want the flange to be created on, and then specifying its length and angle, etc. So in this case, we're going to specify an angle of 75 degrees, and we're going to specify a flange length of 85 millimeters. And once again, we'll make sure that the flange position is specified on the outside, or use the material outside option, and get rid of or untick the offset. We don't want any offset, and specify the relief type to be rectangular, and use a relief ratio of 0.3. If you wish, if the flange is pointing downwards instead of upwards, we can click on the reverse direction option there, and that just brings it up nicely for us. Okay, so once you have all the parameters set, we can just click OK. And the next thing we want to do is complete the closed corner of this flange. So what we do is we click on the close corner option, close corner, and then pick the face that we want to extend, which is this face here. And this will extend out to the outer edge of the flange, and we can specify the type of overlap that we want, or it can either be an overlap, or in this case, we're just going to create a butt option. And this generates the complete box or finishes the complete box for us. So we can now flatten or unflatten the box by simply clicking on the flatten option as shown. So to finish up, let's create a 2D drawing showing the flattened sheet metal box along with an isometric view. So before we do that, just click on the Systems option, go to the Display Style under Drawings, and make sure that the tangent edges are visible. Click OK. So now we'll create a new drawing by clicking on Make Drawing from Part Assembly. This will allow us to drag in the isometric view, which is down here. So let's scroll down, pick the isometric view and drag it in. And then let's make it a little bit bigger by changing the scale. So we'll change the custom scale from 1.5 to 1.3. And the next thing we want to do now is drag in the flattened component. So we can click up, click on Model View, click on Next, scroll down, and we should see an option here for a flat pattern, which is here. Click OK to that. Before we bring it in, let's just rotate it 90 degrees, drag it in, and this will, well, again, let's change the scale from 1 to 5 to 1 to 3, and drag in the flattened component. And as you can see, this has the annotation. It has all the center points, center lines, or bend lines, but it's kind of hard to read. So first of all, we could change the scale. So if you select the whole drawing and click on Font and change the point size to 9, that gives us a clearer font. And then finally, we'll just tidy up some of these, some of the annotation that's on the drawing. So we're going to get rid of some of the notes which are just repeating themselves. So hold down the Control key, pick the notes you want to get rid of, and then just reposition some of the other notes. And once they're positioned to somewhere that's acceptable on the drawing, you can right-click and click on Leader, the leader line, and this will just drag a leader line or narrow in on the annotation. So we do that for all of for the rest of the bend lines as shown, or these horizontal bend lines anyway. And the last thing to do would be to pick these vertical bend lines. So just hold down the Control key once again, pick them all, and then let's just change the orientation by scrolling down to the text format and changing the angle to 0. And this makes it a bit easier to read. So here we have our final drawing, which shows the flattened sheet metal part, along with the isometric view that we want to create.